Throughout the activity today, we're going to review some things and then you'll learn some new items. So you would be given a packet. Take notes on that packet throughout the video. You'll be asked to stop and pause for some on your own and then be able to check your answer. So the first thing we're going to do is refresh on trigonometry on sine, cosine, and tangents, and that is used to find sides and angles of a triangle. So if we're given an angle of 50 degrees, we're going to label what is each part. So know that across from your 90-degree angle is always your hypotenuse. So we're going to label that. With our opposite and adjacent, it depends on what angle we're talking about. So for this particular one, 50, opposite is going to be across from it. If we're looking at this 50, opposite is going to be across from it, here, across from it, and here, across from it. Now with our adjacent, it depends on where our angle is as well. So adjacent means right next to. It's almost like a highway, and then there's a little side road that runs parallel with the highway. Those are adjacent roads. So we'll look at each of our angles. So if we have an angle that is here as our 50 degrees is, adjacent is going to be right next to it here. 50 degrees, our adjacent is here. 50 degrees, our adjacent is here. And 50 degrees, our adjacent is here. So let's label those. So now you see that we have all of our pieces labeled, and this relationship that these have help us with sine, cosine, and tangent. These are ratios. We use an acronym, SOHCAHTOA, Kawatoa, and we have the beginning letter of each one help us with sine, cosine, and tangent. And then the OH and AH and OA help us remember the relationship of the ratio. I'm going to try a few and see what we can find. So let's look at this first one. We have a degree. We are trying to find something that is opposite from it, and we know something that's adjacent. So we know opposite and we know adjacent. Look at our little acronym. We have O and we have A. Well, this has O and H, A and H. O and A is going to be our tangent. So we can take the tangent of 15 degrees and use our ratio of opposite over adjacent, x over 16. And then you're going to solve. So to be able to solve, you're going to multiply both sides by 16 to get rid of the denominator. And then in your calculator, you can actually put this in your calculator. You don't have to put the degree sign, or of course in Desmos, and it will tell you that x is 4.3. Now using decimals is definitely the way to go in Trig, and it's okay. Let's look at the next one. We're given a degree of 35. We know something that's adjacent, and we know hypotenuse. So we're looking for A and an H. So A and an H is the cosine. So go ahead and set up your ratio. Solve. So multiply both sides by 16. Use your calculator, plug it in, and you're going to have 13.1. I want you to try these two on your own and see if you get the right answer. So see how you did on these two? Both of these are sine. And the reason I wanted you to see these differences is a lot of times people will see this angle here, and because this side of 18 is beside of it, they think it's adjacent. But remember, we're always looking for that 90-degree angle, and directly across from that is going to be your hypotenuse. Also, directly across from the largest angle is going to be your largest length, if you remember back those properties from triangles. So let's go to a little bit more complex problems. These are a little bit more difficult. See if you can figure these out. I want you to pause and try them out. So for these few problems, these are your answers. Notice that we had the variable, the unknown, in the denominator. That requires us to do another step. So make sure you understand that. And then on the last two, we actually had two problems because we had two unknowns. I do not ever recommending once you find one of them, so let's say, for example, you found C first, and using that then to plug in to help you find the other missing variable, because you're rounding that, and if you made a mistake, that mistake will just get bigger and continue. So always use your different relationships to find. We're now going to go into a new concept that is finding arc lengths. So first we need to review about circumference. So circumference we know is the complete distance around, all the way around a circle. And the formula for that, if you can't remember, is C is equal to 2 pi r. Now, 2r would be the same thing. Instead of putting that 2 and r in there, we could put it in as just the diameter pi. R is your radius, and then C stands for your circumference. So for this particular one, we're going to go ahead and solve it. So plug in the values and see if you get the correct answer. So for our answer, we've got 100.03, and this is rounded miles. And remember, circumference is just like perimeter. So we're going to talk about using that knowledge to actually find the arc length. Now, arc length is very different from arc measure. We have used the central angle before to find the same measure because central angles would have the same measure as their arc. However, we're finding the length. We're actually wanting to know how far distance-wise that is, not a degree. So we're going to look at how we would do that. So for this particular problem, we have a dashed line that we're trying to find the length of. So that's really important to pay attention to. And we're going to use the knowledge of central angles. So this is a little square, so we know that this is 90 degrees. So if we were trying to find the degree of the arc, it would be the same, 90 degrees. If we notice that this section is a fourth of our circle, we're going to find 1/4 of the circumference. We plug into our formula, what we'd already gotten was the 100.03 miles, and we divide by 4 because taking 1/4 is multiplying by 1/4 or dividing by 4, we get 25 feet. So we know that distance of that blue dotted line is 25 feet. So there is a definite proportion that we can use to find these arc lengths. We're given an example where we know the central angle is 120 degrees. We know what the radius is, and we do not know the arc length. So we're going to use this proportion. The central angle amount divided by 360 and then times their circumference. So we have to know radius, or we can replace the 2 and the r with the diameter. So when I plug in my values, I have my central angle, which is 120 degrees, divided by the total degrees in a circle, 360, and then multiplied by the circumference, having the diameter of 10. I went ahead and simplified 120 divided by 360 is 1/3 of the circle. So this is actually 1/3 of what we're talking about. And then we're multiplying it by 20 pi, which is just the diameter times pi. We could leave it in terms of pi, 20 pi over 3, but that equals, rounding with decimals, to 20.94 centimeters. I want you to try the next one and see how you do. This next one you should have gotten as a decimal 8.38 inches, and that's rounded again as well. In this circle, segment AB is a diameter. If the length of the arc ADB, so we're talking about from here all the way to here, is 8 pi, so they're giving us the length, what is the length of the radius of the circle? So since we know that half of the circle is 8 pi, then we know that the whole circle, the circumference, fully would be 16 pi, doubled. So we can use our circumference formula, plug in what we know, and then solve for r, and we got 8. Or I want you to pause and try and see how you do. Remember to use your ratio and to make sure you understand the circumference formula. Look at these three and see how you did. You should have gotten 46.08 units, 109.96 units, and then for the last one, you're given circumference. You know the central angle, and you're trying to find the arc AC. So your total amount for AC would be 9.